So before my screen recorder crashed, we were working on number 7. And we added square root of 3 to both sides of this equation because we're going to isolate the trig function here. So now we got 2 cosine theta equals square root of 3. Divide both sides by 2 and we get cosine of theta is square root of 3 over 2. Alright, so now let's take a look at our unit circle and figure out which one of these doesn't have a cosine that's radical 3 over 2. So pi over 6, whoosh, cosine is the x part, cosine is radical 3 over 2. 5 pi over 6, whoosh, cosine is negative 3 radical 2. So this one has the opposite cosine. 11 pi over 6 is right here. That's got radical 3 over 2. 13 pi over 6. Well, let's see. 12 pi over 6 would be 2 pi. So then add one more pi over 6. That's 13 pi over 6, the same as pi over 6. So B is the only one that doesn't have a cosine of radical 3 over 2. Alright, so we're going to solve sine of 4x equals 1. So we need to check out our unit circle and figure out when does sine of what angle equals 1. So if I'm thinking about sine of theta equals 1, and then over here I'm going to think, alright, well theta is going to have to be 4x. Let's see, when is sine of theta equal to 1? It's at pi over 2 plus 2 pi n, right? So this is when theta equals pi over 2 plus 2n pi. Because it's here, and then if you add 2 pi, boom, you're back there. Add 2 pi, boom, you're back there. So that means that 4x has to equal this. So 4x is equal to pi over 2 plus 2n pi. And then to find out what x equals, I just have to divide everybody by 4, which is the same as multiplying everybody by 1/4. So I'm going to multiply the left side of the equal sign by 1/4. And I'm going to multiply the right side of the equal sign by 1/4. 1/4 of 4 is 1, so that's 1x, which is x. And then I'm going to get pi over 4 times 2 is 8, plus, and I have to distribute, is going to be 2n pi over 4. So I'm going to thought bubble here for a second. 2n pi over 4. 2 over 4 is 1 over 2. So that's n pi over 2. And that is D. Secant of 3x equals negative 2. So we need to figure out when secant equals negative 2. So when does secant equal negative 2? Well, what is secant? Secant is 1 over cosine. So 1 over cosine of 3x equals negative 2. So if I was to multiply both sides of this equation by cosine of 3x, these would cancel and I get 1 equals negative 2 times cosine of 3x. And then I can divide both sides by -2, and I'm going to get -1/2 equals cosine of 3x. Alright, so now I'm going to think about, alright, well, what angle theta has a cosine of -1/2? So cosine is my x value, and that's -1/2 right here and right here. So at 2 pi over 3, so that means 3x is going to be equal to 2 pi over 3 plus 2 pi, any multiple of 2 pi, so plus 2n pi. And then 3x is also going to be equal to this angle here, 4 pi over 3 plus any multiple of 2 pi. And then we need to multiply these all by 1/3. Multiplying everything by 1/3, and I get x equals, let's see, this is going to be 2 pi over 9 plus, when I multiply here, I'm going to get 2n pi over 3. Then here, when I multiply by 1/3, I get x equals 4 pi over 9 plus 2n pi over 3. So let's see. That looks like A. 2 pi over 9 plus 2n pi over 3, 4 pi over 9 plus 2n pi over 3. So that's got to be A. So we have a mass oscillating up and down while attached to the bottom of a spring. Maximum displacement is 8 centimeters, and it takes 6 seconds to complete one cycle. So that is the period. So the period is 6 seconds. What is the frequency? Well, you need to remember that the relationship between period and frequency is that they are reciprocals. The period is 1 over the frequency, and same thing, frequency is 1 over the period. So our frequency is 1 over 6 seconds, which is 1/6 of an oscillation per second. Okay, so it looks like we've got the same thing going on here. Maximum displacement is 8 centimeters, and it takes 6 seconds to complete a cycle. So I know that the period is 6 seconds, and the maximum displacement is our amplitude. And if the weight is pulled down to its maximum displacement when t equals 0, so if you imagine it's going to start at its maximum negative displacement, so it's going to be starting at -8, and then you're going to release it, the spring, you're going to release it, and the spring's going to pull it up, down, up, and down, and it goes wa-boom, wa-boom. This takes 6 seconds to go all the way up and all the way back down. So the form, if you remember, for this kind of a function is d of t, the displacement as a function of time, is amplitude times either sine or cosine, depending on where you're starting. We're starting at the maximum displacement, So that is modeled by cosine, because cosine starts at 1 and sine starts at 0. So if we were starting at equilibrium, we would use sine. But since we're starting at maximum displacement, we're using cosine. And then omega t, where period is 2 pi over omega. So 2 pi over whatever number's in front of t is the period. Okay, so our amplitude then is going to be -8 because we're starting down 8. And we can pretty much already, we know we're not starting at +8. We know we're using a cosine function. So it's got to be a. But how would we get the pi over 3? What if it wasn't a gimme and we didn't know it was pi over 3? What if we had -8 cosine pi over 3 and we had -8 cosine 6 pi or something like that? And you're trying to figure out which one of these it is. Well, here's what you would do. You would use period equals 2 pi over omega. We know that our period is 6. 6 equals 2 pi over omega. Multiply both sides by omega to get it out of the denominator. So we got 6 omega equals 2 pi. Then to get omega by itself, we're going to divide both sides by 6. And omega equals 2 over 6 reduces to 1/3, so that's pi over 3, and that's where we could find the pi over 3. So here you'll need the formula that period of a simple pendulum is equal to 2 pi times the square root of the length of the pendulum over the acceleration of gravity, which is 9.8 meters per second squared. And then we want to find the length. So if I wanted to find the length, I would start by dividing both sides by 2 pi. So then I got period over 2 pi equals square root of length over 9.8. Then I would square both sides to cancel out the square root here. So that gives me t squared over 2 pi times 2 pi is 4 pi squared. And that would be L length over 9.8 meters per second squared. Then I'm going to multiply both sides by 9.8 meters per second squared. And I get pendulum length is 9.8 meters per second squared times the period squared, which is going to be in seconds squared, over 4 pi squared, which doesn't have units. The second squares will cancel out and length will be in meters. So I just need to plug in 9.8 times the period is 13, so 13 squared over 4 pi squared, and then punch that in my calculator. 9.8 times 13 squared divided by 4 pi squared equals 41.95 meters. Alright, I'm going to have to do part 3 video, so check back in for part 3.